Hello everyone. So I wanted to do just a quick video going over how to set up and use the built-in debugger in VS Code. I've been seeing a ton of people having trouble debugging or not using a debugger at all, finding that GDB is challenging to use or complicated or intimidating. And I think this might help some of those people and help you debug your code more quickly and more easily. So what I have here is a really simple C program. It's essentially just, I have an animal struct, I have Leo the lion, and Zoe the zebra, and I'm looping through until the lion's location catches up with the zebra location. I also have a really simple .h file that defines that struct with the name, speed, and location, and I have a really simple make file that will compile that executable. So if I open the terminal and I just compile this program, I will get an executable called example, and if I run it, we get Leo the lion caught Zoe the zebra. So right now I don't have any bugs in this code, but let's go through how I might go about setting up the VS Code debugger for this program. So to start, you're going to want to click on this Run and Debug window over here on the left, and if you open that up, you'll see you have a link here to create a launch.json file. You're going to want to click that, and that will create the configuration file for the debugger. It's going to be blank to start with just a little bit of boilerplate, and you want to go into between these two brackets and click Control Space. That will open up IntelliSense. We're going to want to click this second one here, the one that says GDB launch for C and C++. The VS Code debugger is a wrapper around GDB, so you can do pretty much anything you're able to do in GDB in the VS Code debugger, but with a nicer interface. If we click that, it'll fill in some example template language. You're really going to want to change just one thing to start. You'll notice here this little program field that says full path to program executable. You're going to want to change that to the name of your executable. In my case, that's example, but that could be whatever the name of your executable is. You do want to make sure that the .vs code folder that is created with the launch.json is in the same folder as your code. Otherwise, this won't work. Okay, so if we save this and we go back to the debugger, you'll notice now that this window has changed to a sort of three-panel view of variables, watch, and call stack. And I'll get to what each of those means. But if we go to example.c, first of all, we need to make sure that we've made the most recent version of the executable, otherwise this won't work. You also need to make sure that in your makefile you have this -g flag that puts in the information into the executable so that GDB, and therefore the VS Code debugger, can understand the contents of your source code while it's going over the executable. So once I click this little play button, the debugger will start. In this case, it ran through and exited normally. Nothing happened. So you ask, what is the point? Well, if we add a breakpoint by clicking over on the left-hand side of your code, right next to where the line numbers are, you can add one of these breakpoints. These are super critical when debugging, and they help you to step through your code piece by piece. So if I click play again, a shortcut for that is F5. We'll notice that the debugger stops on this first line where I put the breakpoint. You can see the values of everything, and this looks sort of weird. And the reason for that is neither of these structs have been initialized yet because we haven't run this code yet. The program right now is stopped before the line that's highlighted in yellow. So it hasn't run this code yet, and it won't run it until we step through and execute that line. So you'll notice when you run the debugger that a little window shows up here, and you can use that to control the debugger. This button here, the little curvy arrow, is to step over your code line by line. This button here goes to the next breakpoint. I'm going to start by stepping over line by line. If we step once, we'll notice now it's initialized this struct, Leo the lion, with a speed, a location, and a name. And if we step over again, it's run that line, and it's initialized Zoe the zebra with a speed and a location as well. So now we've gone into the loop. So it's done the check, and while true will always evaluate to true, and it will always go into the loop. And then it's doing this check. It's saying, is line location more than zebra location? In this case, line location is not more than zebra location. It's 0 versus 10. And so this shouldn't execute. And you'll notice that the debugger doesn't run these lines of code, the printf and the break, because the conditional did not evaluate to true. So then it runs this, and you'll notice line.location plus equals line.speed, and it's done that. The location is updated now to be what it was before, which was 0 plus the speed, 22. And you'll notice the same thing is about to happen here. So watch. As I step over in the next line, the location has updated for the zebra as well. So you can kind of see the variables as they are changing while your code is running. And that way you can sort of watch and see if they match what you'd expect. And if they don't, that's a really good place to start thinking about where that bug occurred that you're trying to solve. So we can keep stepping over this loop, and it'll keep looping through. And eventually, the location of the line is 66. The location of the zebra is 64. Leo has caught up with Zoe, and it'll print that to the console here, and it'll break the loop, and the program will exit, and the debugger will close. So that way we can kind of, on a really granular basis, see how our code is working and understand how to solve any bugs that come up. If you run into a segmentation fault, for instance, the debugger will stop and tell you what the values of all your variables are at the point of the segmentation fault. And it will tell you exactly where the segmentation fault occurred. And all sorts of things like that that are super helpful. There's also this window call stack here. If I run the debugger again, you'll notice that it gets populated with this main function. But if you call another function inside the main function, that will get popped onto the call stack here, and you can hop between different parts of the stack by clicking on them down here, and it will fill in the variables, the local variables for that particular frame in this window. So you are not limited to like the topmost frame on the call stack when you're stepping through. You can add as many breakpoints or as few breakpoints as you would like. And that is sort of how you use the debugger, generally speaking. Now, there's a few extra configuration options that we can add to allow us to put input into the debugger. So for instance, in our first pset, we have to process files as command line arguments. If you want to pass command line arguments into the debugger, you need to go into launch.json, and you'll notice this args field here. It's sort of an array of strings. So if we wanted to pass, for example, hello.txt and bye.txt, our program won't actually look at these, but we can sort of see what they'll evaluate to. So this would be essentially equivalent of running /example hello.txt bye.txt, right? So each space is like one argument. So if we run this, I'll get rid of some of these breakpoints. You can also see your breakpoints down here. We'll notice that argc is now 3 instead of 1 before, and argv is an array of strings. Now, we won't be able to see the other values of the array because all an array is a pointer to the first element. But if we go into the debug console down here, we can then execute more advanced queries on our data at that point that we currently are in the debugger. So if we want to get argv1, we can execute that, and it'll tell us it's hello.txt. And if we want to do argv2, we can get bye.txt, and argv0, which is the name of the executable that's running, etc., etc. You can do this for any variable that's currently within scope. So it's a really powerful tool. Also, you can execute code too, so you can change the value of things right here in the debug console. You might notice a few things that just to be aware of when you're using the debugger. First thing is you need to make sure to remake the file each time you use the debugger. Or rather, each time you change the code, you also need to remake the executable. Otherwise, the debugger will be out of sync with your code and things won't make sense. So every time you change your code and you want to rerun it with the debugger, you should run make for your executable. The other thing to be aware of is sometimes because of how symlinks work in the zoo, your code sort of won't match match up exactly. So if I open this file up and I click debug, sometimes it'll open another file in a different window like this. This is where it actually is on disk, and this is like the symlinked one that's open in VS Code. You can just go ahead and close this. They're actually the same file, just a different address. So that will maybe look weird, but just don't fret. It's totally normal, and you can just treat the file that the debugger opens as the file that you want to deal with. All right, that's about it. Hopefully that makes sense. Hopefully that helps you debug your code more easily, and I wish you all luck with your first problem set.